Welcome back. Well, we're about to take another step in a great direction. You see, when people hear math, they're scared of usually like two things. Firstly, fractions. And your fraction, no. Or secondly, this idea of graphing. Graphing tends to be one of these concepts that people just really struggle with. And so what we're going to unpack under the next many videos is how to take some really good steps on getting some success with graphing, becoming really good at graphing. And where it starts is just understanding how graphs work, and really the tools that we use to create graphs. And where that begins is with something called the rectangular coordinate system. There's other names for this. There's the XY plane, there's the Cartesian plane. We'll get into some of those names as well in just a minute. But we're going to get a good feel in this video for the tools that we use to graph, the tools that we use to relate two numbers to each other. So we really don't want this idea that graphing is super difficult. It can be really hard, but if we understand the tools, generally graphing becomes a little bit easier. So we're gonna deal with that today. Now, the idea why we even have this. Well, you see, when we start considering the relationship between two numbers, we need more than a one-dimensional way to relate them. So we need more than just a single number line. Sure, you can relate one number on a number line very easily, but if we want to create a relationship between two numbers, hence the idea of relating two variables, a variable with another variable, we're going to need two number lines. That's where this rectangular coordinate system or the XY plane or Cartesian plane comes from. Basically, all we're really doing is we have the intersection of two never-ending number lines, and we relate them at a right angle or a 90-degree angle or at this relationship we call perpendicular. That's basically the forerunner of everything we have graphically in two dimensions. Is we have this horizontal number line, which we're going to call that something in just a minute. We got this vertical number line, which we're going to call that something in a minute. I'll show you exactly how they work, and we intersect them. That's it. That's all the rectangular coordinate system is. And then we discover ways that we can relate these. So I said there's a couple other names that you might hear. The XY plane is one of them, because what we call these horizontal and vertical number lines are axes, or individually that'd be an axis. So we're going to have an X axis, we'll have a Y axis, and if you put them together on a flat surface, you can have what's called an XY plane. There's also something called a Cartesian plane. That's a kind of an interesting story. The legend has it that a guy named Rene Descartes lived a long time ago. He was kind of a sickly fellow, took really long baths, and so the story goes that one day he was sitting in his bathtub and he's looking up at his ceiling, which the ceiling, of course, walls meet hopefully at a 90-degree angle if you're living in a rectangular house. And he was looking at the ceiling and he was noticing this fly walking along the ceiling, and he goes, huh, you know what's weird? I can map where that fly is by counting over a certain number on this one wall and up a certain number on this other wall, and I can map where that fly is traveling. And so the theory has it he was one of the first ones to come up with this idea of two axes, two number lines intersecting one another at a right angle. So we coined the Cartesian plane after Rene Descartes. I don't know if the story is true or not, but it's kind of a fun story. So we have three ways that we can name this idea of having these two number lines. Rectangular coordinate system, very common. XY plane, because we have the names of the axes that they're given to you, or Cartesian plane, they all mean the same thing. Basically, it's just this. It's an intersection of two never-ending number lines. The horizontal one, we have a name for it. Hopefully this is making sense to you why we need this, though. I really don't want to skip over that. Why we need two number lines rather than just one. One number line is great if you're only dealing with one variable, because you can pick a number, put it anywhere on there. If you ever want to relate two variables, you're going to have a relationship amongst two numbers. We need a way to represent that relationship. A one number compared with another number, well, you don't really want to have them here because you can't show a relationship very easily. We put them one horizontal, one vertically, and we can show where these numbers interact. That's the nature of why we need this so far. So we have this horizontal number line, which we're seeing here. That's called the x-axis. Almost always we're going to have an x-axis that's running horizontally. Now, in the future, when you get to Calc 3, I'm like, that's a long way. I know, but you can do this. So, and it's still kind of the same relationship. We just come out this way, kind of flip around a little bit, but we might have an XYZ axis, a three-dimensional coordinate system. That's okay. Right now, almost always for you, your horizontal axis is going to be the x-axis. And we label it right over here with just an x. Now, we do need to understand that these number lines, they're never ending. They go to positive and negative infinity all the time, so they don't end. This thing theoretically goes forever and ever. Then we also have this horizontal number line. The one going up and down, it's called the y-axis. So x-axis is going to be horizontal for us. The y-axis is the vertical axis. Yeah, sure, it goes on forever. Now, they intersect. If you have a horizontal line and that goes forever, all right, and you got a vertical line that goes forever on the same plane, at some point they are going to intersect. They have to if they go on forever and they don't have the same slope. Slope is something we're going to unpack way later, okay? So this is just getting us rolling on this. I spend the next lots of videos talking about how to get you really good at graphing lines. Later on, we're going to talk about parabolas, all sorts of shapes. Right now, it's just about lines, and it starts right here with really understanding how this stuff works. So we have a never-ending number line called the x, a never-ending number line called the y. They're perpendicular, which means they have to intersect in a plane. What we call the intersection is called the origin. So horizontal axis, that's the x-axis. The vertical number line or axis is called the y-axis. And where they intersect is called the origin. Now, we have to choose. We got to choose what the positive and the negative direction are. So probably the x-axis can be really easy because it looks like a number line already. If I just remove the y-axis, you have a number line. It'd be not bad. You're going to have a 0 on it. You're going to have some positive numbers increasing forever and negative numbers increasing forever. So just like we dealt with in inequalities, and hopefully you've watched those videos, our positive numbers go to the right and our negative numbers go to the left. So when we're dealing with our x-axis, we have numbers positively increasing as we move to the right. So 1, 2, 3, 4. Now I can't write forever, but these numbers go forever, never, never. What number is going to be in the middle? Well, what number is going to be right here? Well, we're going to choose this intersection. We're going to choose this intersection of the x and y axis to have an intersection on the x-axis of 0 and an intersection on the y-axis of 0. So right in the middle, this origin, where they intersect, we have a coordinate of 0 on the x-axis. We're also going to have a coordinate of 0 on the y-axis. We're choosing to base our number system on that intersection. So it's not that they magically intersect at 0, 0, or well, 0 on the x and 0 at the y. We're choosing to start our numbering system from that point. So we start at 0 on both the x and the y. Well, what that means is that if our positives move to the right of the y-axis, look at that. Y-axis is kind of our starting spot for our numbering here along the x. I know that's kind of weird. It's kind of, what are you talking about? Our y-axis cuts the x-axis. Where it cuts the x-axis, we call that 0. So to the right of the y-axis, along the x, we're going to have our positive numbers. To the left of our y-axis, along the x, we're going to have our negative numbers. It's just a number line. We're just calling where the y-axis intersects the x-axis. We're calling the origin, and we're calling that 0 on the x. So we'd have the same exact scale, but moving negatively to the left along the x-axis. Can you see the number line? Can you see it's just basically like we had in the past? We just have another axis. That's all this is really talking about. It's kind of combining, joining, intersecting two number lines, one's perpendicular to the other. So we also have to choose what's positive and negative along the vertical axis, the y-axis. And it's because we have this idea that up must be good or positive, that's what we choose. So going up along the y-axis vertically, we're going to have positive numbers. Again, it's not magic that this is going to intersect at 0, 0. We're calling 0 along the x and 0 along the y, we're calling that intersection the 0 spot of our horizontal axis and the 0 spot or the starting spot for our vertical axis. So we're calling that 0 here as well. So we're going to have to choose something and keep it consistent all the time. Along our x, right is positive, left is negative. Along the y, up is positive, and down is negative. So, same scale though. Generally, we keep the same scale for our rectangular coordinate system along the x-axis and along the y. If we don't do that, sometimes we can skew our graphs. They're not going to look like they're supposed to look. However, sometimes with scatter plots, we do this on purpose. I'm going to give you an example at the end of the video where I talk about how to make a scatter plot. So be sure you stay around for that one. So we're going to continue climbing and climbing and climbing, getting positive towards positive infinity. And it goes forever and ever and ever. So positive numbers climb upward along the y. Downward, we're going to get our negative numbers. And that's really it. You can call that the rectangular coordinate system. You can call it the xy plane. Why? You have an x-axis, you get a y-axis, and they're on a plane. It's kind of straightforward. Cartesian plane, not a lot of people use that very often, but I told you where that comes from. Essentially, that's the idea. Horizontal axis, number line, positive right, negative left. Vertical axis, that's the y-axis, positive up, negative down, where the intersect's called the origin. Now, before we get to how to plot some points, we're going to do that really quickly because you're going to need to know how to do that very, very well. Now, you see, the first technique, and I'm going to lead you kind of to the next few videos, the first technique in how to graph lines, we're talking about linear equations. The first idea on how to graph lines is through plotting points. Just figuring out some points that are on that line and putting them up there and drawing a line through them. I'm going to lead you to that in the next few videos. So right now, though, we're just interested in how to plot points. We're going to get there. Before we do that, there's how many pieces to this graph? How many kind of squares or rectangles do you see there? What's it cut the plane into? So if you imagine this whiteboard as a plane, there's really how many parts that this rectangular coordinate system cuts it into? Well, let's count them. I got this part going here forever. This number line, basically a number line cuts the entire universe on a plane into two parts, the top part and the bottom part. So you can imagine if I took this x-axis and I extended it forever like a knife through the plane, there's going to be a top part, there's going to be a bottom part. Now if I extended this y-axis forever, there's going to be a right part, there's going to be a left part. If you put those ideas together, well, then you have a top right part, you have a top left part, a bottom left part, a bottom right part. You have four what we call quadrants. Now, we agree in math on how to number these quadrants. So the top right part, where, check this out. This is important that you get this, okay? Don't miss this. Don't zone out right now on my voice, okay? Just kind of focus here. Where your x numbers are positive and where your y numbers are also positive. So in this region, your x's are positive numbers. Your y's are also positive numbers. They're both positive numbers. That's quadrant 1. So we're going to call this using Roman numerals, quadrant 1. How we label our quadrants is working our way around counterclockwise. The reason why we work our way around counterclockwise is convention. We could have done it this way, I suppose, but we've all chosen to go quadrant 1, 2, 3, and 4. We don't skip around. So quadrant 1, cool. Quadrant 2. Now, right now in your head, can you think about what the values of x would be and what the values of y would be in quadrant 2? Ask yourself that question before you move on. Are the x values positive or negative in quadrant 2? Are the y values positive or negative in quadrant 2? Think about that right now before I get to it. Well, in quadrant 2, x values are moving to the left of 0. That's got to be negative x values. So every point, which we're going to get to in a minute, every point over here is going to have x values which are negative. Every point over here in quadrant 2 is going to have y values that are what's above the x-axis. Those are positive numbers. So this is interesting. Well, we deal a lot in trigonometry when we get there with the value of Sine and cosine, I know those are foreign words to you right now, it's okay. They relate to x and y. Values of sine and cosine as being positive or negative in a certain quadrant. It's really important that we get that. So right now I'm going to try to build that for you. In quadrants 1 and 2, the y values have to be positive for both those. Look at that. All these points are above the x. Okay, that correlates to a positive y-axis. All of these points over here are going to have y values that are positive. I know you don't understand why that's super important now, but you will, I promise. I will explain it to you as we get to trigonometry, okay? But right now it's really important for you to understand the value of the variables compared to the quadrant that they're in. So every point in quadrant 1 is going to have positive x's and positive y's. Every point in quadrant 2 is going to have negative x's. Look at your x values. They're over here on the left side of the y. Negative x values, but positive y values. Think about these values. What can you tell me about quadrant 3 with their x values? What can you tell me about all the points in quadrant 3 and their y values? Well, let's look at them. All these points over here are below the x and to the left of y. That means if they're to the left of y, they're going to have negative x values. If they're below the x, they're going to have negative y values. These points over here are going to have x values, which are all negative, and y values, which are all negative. So let's do like a 10-second recap. Our goal is to find a way to relate two values. We call those values x values and y values. We can't use one number line anymore. That would just be x, or that would just be y. We're joining them. We're comparing the number, or we're creating a relationship between those numbers. So we need two number lines to put them together. How we choose to do that is by joining these x and y in what's called an ordered pair. We're going to get to it in a minute. Right now we're talking about quadrants. Since these two number lines intersect and they're perpendicular, they're going to create 4 spaces, so 4 separations of your plane. We call them quadrants, we number them counterclockwise, and now we're discovering the relationship between these quadrants and the values of x and y. Quadrant 1, all positive. Quadrant 2, x is negative, left of the y is positive, above the x. Quadrant 3, both are negative, left of the y-axis, those are negative x values. Below the x-axis, those are negative y values. Quadrant 4, the last one. At this point, I'm hoping you get it. You probably should be able to write down on your own, my x values are positive or negative. My y values are positive or negative. Well, let's look at it. If you had to put a point here, which we're going to be doing in just a minute, the point relates an x to a y. Over here, these points are going to have an x value that's positive. They're going to have a y value that's negative, all of them. So, answer this question. What's the only quadrant that has a negative x value but a positive y value? Negative x but positive y. Quadrant 4? Now, negative x has to be on this side. Positive y has to be on this side. Therefore, it's got to be quadrant 3. Or quadrant 2, I'm sorry, I misspoke. What quadrants have positive x values? Positive x values, that's this side. Positive x has to be over here. Do both of these quadrants have points that have positive x? The only points that don't have positive x's are here. So yeah, all the points with positive x coordinates, positive x values, are to the right of y. Quadrants 1 and 4 have positive x values. That's the idea. Start asking yourself those sort of questions like, yeah, well, how would I find all the points with negative y's? These are all negative y values. Yeah, negative x values, positive x values, but everything that had a negative y value would be in one of these two quadrants, quadrants 3 or 4. That's the idea on how quadrants work. They're counterclockwise, starting in the upper right and moving around to 1, 2, 3, and 4. We start with all positives, maintain positive for y, both negatives, maintain negative for y, and this one exchanges to a positive. Now, take a break to let that sink in. Get really familiar with the number lines, where positive x values are. That's why we just did that for like 5 minutes, on what positive x's are, what positive y's are, where they are compared to the quadrants. Because right now what we're going to get into is how to plot points. So I've talked a lot. I've talked about x values, y values. I said the word coordinate to get you prepped for this. We're gonna create these things called ordered pairs. You see, when we have two numbers, we're trying to relate them, we have to show the relationship. We have to come up with a system to get the relationship between the numbers on something that shows the relationship. A number line's really easy because a number line you go, 3, it's here. -5, it's here, done. But how can I relate 3 with one number, or one variable, we'll say, with -5 on another variable? I can't use the same number line. That's only one variable. That's where this comes from. I'm going to show you how to use it. So how we put points on a graph, how we put points on a rectangular coordinate system or a XY plane, a Cartesian plane, is with something called an ordered pair. There's a, by the way, in math, we're not very inventive. We basically just call things how we use them or what's used in them. So an ordered pair tells you that there's two numbers. They're always going to have the same order to them. So we're not going to switch around what variable comes first, what numbers come first. An ordered pair for us, for rectangular coordinate systems or XY planes, always pair up two numbers inside of parentheses where the x value comes first, always. And the y value comes last. So we have these two numbers that, they're now in a relationship. And now since we know all x values go positively to the right, all y values go positively upward, we can put these ordered pairs in relationship on our plane. It's kind of cool. Which, if we know how to use a number line, which you do, you're pretty good at that. We know how to put numbers on this number line. We would know how to put y numbers on this number line. We can now combine those ideas to plot points. That's neat. There's a couple notes I want you to have down before we actually get into this. Number one, these ordered pairs are in alphabetical order. So x is always going to be first. In other words, I want you to break the thought that we always use x. We do most of the time use x. But if you don't use x, the first number relates to your horizontal axis. The second number relates to your vertical. It's convenient for us that it's alphabetical order for us. So when I say x is always first, what I mean is the horizontal axis is always your first number in an ordered pair. The vertical axis is always the second number in an ordered pair. When you get to x, y, z, that's also in alphabetical order, and there's an ordering to that on how to plot points in 3D. It's not that easy, but you can do it. So I'm going to write this down as x is always first, because I'm saying the horizontal axis here. Conveniently, it's in alphabetical order. So that's important. We need to know that our horizontal axis number in our ordered pair is always the first number that we consider. The x number, always first. The y coordinate. The y coordinate just says the y number on the number line. That's really all it's saying. So coordinate's a fancy way to say number on a number line that we're putting together to make up this point. X coordinates first, the y coordinates second. It's in alphabetical order. And one big thing, we spend a whole lot of time talking about interval notation, right? We do, hey, these are the numbers from -infinity to 3, or from 5 to infinity, or between -7 and 5. Please listen, don't miss this. This is, in my opinion, kind of just a notation failure on math people's parts. I guess we run out of symbols or something. This is not interval notation, even though it looks identical. I get it. You got to think about the context of how we're using it. When we're talking about inequalities, and we use parentheses with a comma between them, yes, we're talking about an interval of numbers that satisfies this given inequality, and that's fine. When we're talking about a rectangular coordinate system, this no longer means a range of numbers. Please get this. What this represents now is a specific point on a plane. That's it. So we need to look at the context of how we're using our symbols to dictate what we're talking about. When we're talking inequalities, yep, you bet, interval notation. When we're talking about a plane, no, we're talking about a point on that plane. That's it. How to relate these two numbers to one another. That's how this notation works. So I'm going to make a note here. Make sure it's on your notes. Make sure you get this down. This is not interval notation any longer because we're not talking about inequalities right now. So let's get to it. I'm going to erase the quadrants. Right now, all you really need to know is that we're relating not just one number on a line, we're relating two numbers to each other. We have to use a plane. One number, you got one dimension basically. Two numbers, you got these two dimensions. Three numbers, you'd have to have a third dimension. Right now, we're relating two numbers to each other. We use that with a plane of two number lines that intersect somewhere. Where they intersect is called the origin. Positive is up, positive is right. Negative is left, negative is down. We need to have this ordered way of doing things so we all get the same points at the same time. We call that an ordered pair of numbers. X, our horizontal numbers first. Y, our vertical number, comes second. And this is not interval notation because we're not talking about inequalities any longer. Quadrants start with all positive, X positive, Y positive, and work their way around counterclockwise. Right now, it might be a good time for you to pause this or just stop it for a second. Think through if you understand the relationship of your number lines. Think through if you could think about what values are positive and what values are negative for each quadrant. Do that real quick. Okay, take just a moment and do that. So since you've done that, since you have it down, now we get to talk about actually plotting points. It's not really hard, but it's really important to get right, and that's different. Something that's not hard can still be difficult to get correct if you don't understand the way to do it. So I'm going to give you just a series of points that we're going to plot on this particular XY plane, so you understand exactly how to do it every single time. It's not going to take a whole long time. One thing that we are going to do is we're going to go backwards and forwards. So when you get to whatever practice you're doing, I don't know where you're getting that, but you need to be able to take an ordered pair and get a point, or look at a point on an XY plane and get an ordered pair from it. By the way, that word for points on a plane that are not connected in any way, shape, or form is called a scatterplot because they're just scattered up there. They do show relationships sometimes, and we'll talk about that in the last example that we have for this video. Also, one last thing. Points are typically labeled with capital letters. That's it. So we have point A, capital A, B, C, and D. So we're going to do that. We're going to have some points. We'll put them on our graph. If you want to, I'm going to put them all up there. So if you want to jump ahead, pause the video, and just see if you got them right, that's great. If you've had exposure to this, you probably know at least a little bit about how to go about it. So let's talk about point A. I want point A to be the ordered pair 2, 3. We'll talk about the relationship in a moment. As you go through it, if you're going to do this on your own, I want you to think about every time you plot the point, what quadrant this is in. Is it in a quadrant? Is it on an axis? Is it at the origin? Think about those key words. I want you to start stimulating that in your head. I'll leave J because I don't want to scare you or piss you off right now with fractions, but you're going to have fractions. Let's start plotting them. So let's look at the point A. So now that we've gotten a letter, we can talk about it. That's kind of nice. So we can refer to A, and we all know that that's going to be the point that's located at 2, 3. First thing I need you to do with any point is identify what the X value is and what the Y value is. So right now, the X value is, think about it in your head. What's the X value here? Remember, they're in alphabetical order. So X for us is the first number. It's got to be positive 2. That tells you something. That tells you right now, don't even look at the graph, think through this. That tells you right now that the point A must be to the right of the y-axis. Think about that. The y-axis cuts the x-axis in half. Has to, goes right through 0. So if our x value is 2, it's going to be to the right of the y-axis, somewhere over here. That's kind of neat. That's how this stuff works. Don't just get in the habit of plotting points. Think about where these things are located first. So x is going to be to the right, the 2 is going to be to the right of the y-axis. 3, well, 3 is our y value. If it's positive, it has to be above the x-axis. The x-axis cuts the y right in half. Positive numbers are above, negative below. So if x is 2, it's to the right of y. Get that? If y is 3, positive, it's going to be above the x. That puts it clearly in what quadrant? What quadrant was this one? Quadrant 1. It's got to be up there. So how these ordered pairs work, how plotting works, we read our first number, says, the x number, it's somewhere on the horizontal line. It's the first number that we have. If you need to write it down, if that's you, that's totally fine. Write a little x and a y. It's alphabetical order. The horizontal axis is first. Since we've labeled it x, that's an x value. The second number is always the vertical axis. Since we labeled it y, that's a y value for us. So the first number says, hey, you're going to go to positive 2 along the x. That's got to be over here, to the right of the y-axis. Then you're also going to go to positive 3 along the y. So we've used our x-axis first. Then we're using our y-axis to get that positive 3. Where do those come together? So we don't put a point here and a point there and draw a line. That's not what we're doing right now. If you've had exposure to linear equations at all, as far as graphing them, we do some of those techniques. But it takes 2 points to graph a line, not 2 numbers in 1 point. There's a difference there. We need an A and a B, not just an A and use the numbers. That's not how we graph lines. We're going to use 2 points, but it has to be 2 points, not the numbers or coordinates from 1 point. So yeah, this is the x value of 2, this is the y value of 3. Where do they come together? That is your point. So we're using a conjunction of these 2 number lines to get some point in space, in a quadrant. That's interesting. You don't just have numbers on a line, on an axis right now. You have where they're at. Think about René Descartes and his fly. There's no way to tell where the fly would be on the ceiling if the fly had to be along the edges of the wall. That's impossible. In order for the fly to be on the ceiling, you use your edges to map the fly. So it's along a certain x, it's along a certain y, but it's in space somewhere, a lot of the time. And we're going to label that point A. Looks about right. I'm going to erase this so it doesn't get confusing. That's where our point A would be. It's at the coordinates of 2 along the x and combined with, related to, 3 along the y. Where those ideas rectangularly, notice how we made a rectangle out of that? Interesting, right? Come together, that's your point A. We're going to go quickly through the rest of them. If you want to try them on your own, I would very, very much encourage you to stop this and try those points right now. So the point B. Point B says, hey, along the x-axis, I'd still be 2. Remember, x is always first, y is always second. Horizontal is first, vertical second. I'm going to go to the same 2, same exact 2, but look what the negative 3 does. The negative 3 for the y value says, I'm no longer above the x. Since I'm negative, I have to be below the x, considering the y value. So I'm going to come down here. You can still make your same rectangle, use your vertical value or vertical lines here to create this line at x equals 2, at y equals negative 3, and where those ideas combine rectangularly, you get this point B. If I'm making sense to you right now, you should be able to do the rest of them. So if you didn't take my advice and stop it at this point, do the rest of them. I'm going to go quickly and, of course, explain it. Also, one more thing. Can you think about how you'd be able to go backwards? Could you see that? Could you see it if I asked you, hey, what's the coordinates for point A? You go, well, what would you deal with first? Would you look at the y value or look at the x value first? It doesn't really matter as long as you know where to put those numbers. The x number has to go first in your ordered pair. So I'd look at x first. Well, looks like I'm about 2. I'm exactly 2 on the x-axis. This way, considering just movement along this number line at 2. Considering movement along my y-axis, I'm at 3, so my coordinates would have to be 2, 3. Think if you can go backwards as soon as you plot these points. So we're going to move on. C. C says negative 1 along the x. Our first number is x. Here's negative 1. I'm not going to put a point there. I'm going to look at my y value of 4. So negative 1 for the x combined with the idea of positive 4 with the y. So here's negative 1 here along the x. Here's positive 4 along the y. Where those ideas combine. So along the x, I've got to be in this vertical line. positive 4, I've got to be in this horizontal line. Notice how they parallel one another. This has to be C. Let's move on with this one. D says negative 2, comma negative 4. The x value is negative 2. It says I'm along the x-axis in this level, this the kind of column if you want to think of it as a column. Negative 2 here. I'm also negative 4 along the y-axis, which means I'm dropping below the x-axis. Looks right about there. Make sure you're labeling your points. How about E? E is a weird one. What the heck? E says, what's your x value? What's your y value? So E says, I want you to go to the x value of 4. Got it. Nailed it. But then I want you to go to the y value of 0. So, where's 0? Do you remember this? Remember like 5 seconds ago? Well, probably like 10 minutes ago now. How the x-axis cuts the y value, and where it cut the y value, or y-axis, that value is 0. We identified it as that. We made it that. So anywhere, this is weird, I need you to get it, anywhere along the x-axis, you have a y value of 0. Anywhere along this height, you'd have a y value of 1. A has a y value of 3, doesn't it? It's at the height of 3. A C has a y value of 4. It's at the height of 4. Every value, every point along the x-axis has a y value of 0. Because if these are perpendicular, all of these are going to be at the same height according to the y. So basically, E's telling you, hey, go to 4 along the x, but don't go up, don't go down, don't go positive, don't go negative. Stay right in the middle of positive and negative. What number is right in the middle of positive and negative? 0. Don't go anywhere. Stay right there. Now, I'm going to take a moment to ask you some questions. I need you to get these like Johnny on the spot. I haven't used that in probably 14 years, but I'm going to use it here. Johnny on the spot. That means quickly. What quadrant is A in? You got to be quick about it. What quadrant is A in? What quadrant is C in? A's in quadrant, positive x, positive y. It's got to be quadrant 1. C is in quadrant 2. We're moving counterclockwise. Negative x, positive y. How about B? What quadrant is B in? B's got to be 4. Now, how about E? What quadrant is E in? None. It's on the x-axis. It's not in quadrant 1. It's not in quadrant 4. It's splitting quadrants 1 and 4. That's exactly what the x-axis does. It splits quadrants. So E's not in a quadrant. You'd say it's on the x-axis. Let's talk about F. F says kind of something similar to E. It says, hey, I want you to go to negative 2 on the x-axis, but I don't want you to go up or down. I want you to stay at 0. 0 is the number that splits positive y values from from negative y values. So we're going to label that F. It's not in quadrant 2, and it's not in quadrant 3. It's right in the middle of that. Because, well, we don't have a positive y putting us in quadrant 2. We don't have a negative y putting us in quadrant 3. Right in the middle of that. It's on the x-axis still. G says, well, we have an x value, an x coordinate of 0. So I don't want to move positive. I don't want to move negative. I want to stay right here at x equals 0. But then I want to move, well, where? What's the other point that we're relating it, or other value, I should say, other coordinate we're relating it to? I want an x value of 0. Verify something for me. Think about this. Does every single point along the y-axis have an x coordinate of 0? If all of these are positive x values, and all the points over here have negative x values, the point on the line that separates those two, call them half planes, half over here and half over here. If all of these points on this side of the universe on this plane are positive x's, and all the points on this side of the universe are negative x values, all the points on this line have 0, the number that's between positive and negative. All of these have 0 x coordinates, well, x coordinates that are 0. So 0, 1, 0, 2, 0, 3. What I'm asking for is stay on that, stay right between. So stay at x equals 0. Don't go right, don't go left, stay right there, and then go to a point that has a y coordinate of 1. So stay here for x, but also have a y coordinate of 1. The next one, 0, negative 3. Oh, yeah, the quadrant-wise. Quadrant 1, quadrant 2. X-axis, Y-axis. This would be on the Y-axis. It's not in a quadrant. It's separating quadrants 1 and 2. Very much likewise here. X value is 0, Y value is -3. I'm hoping at this point that you're getting it, that you really understand how to plot some points. Lastly, 0, 0. We talked about it. In fact, it's how we identify where our number lines start. Where our axes come together in space on the plane, we define that to be the origin. We start our numbering from that point. So we start our numbering from the origin, positive right, negative left, positive up, negative down, and this would have to be at the intersection of 0 and 0. It's 0 on both number lines. So 0, 0, that is our origin. So you would say, well, what would you say about it? Is it in a quadrant? No. Is it on an axis? Actually, it's on both. It's the only point in the world that's on both axes. It's the origin. It's got to be on both, but that's where they intersect. Interesting. So we can say this is on the x-axis. We can say I is on the y-axis. I is on the y-axis. Or we can say I is the origin. All those statements would be correct. Lastly, this gets a little awkward, but could you graph fractions? Well, sure. You're just not going to have something, if you have like a grid, it's not going to be on an intersection of a vertical and horizontal line. Graph paper is awfully nice for this, by the way, because you can just follow your grid. Fractions wouldn't be there. So 3/4, comma, -1/2. Well, let's think about that. Everybody right now, I want you thinking, what's the x-coordinate? Is the x-coordinate positive or negative? Does that put you to the left or the right of the y-axis? If you're able to answer those questions, you've learned something you know about your graphing, okay? How about the y-coordinate? What's the y-coordinate? Is the y-coordinate positive or negative? Does that mean you're above or below the x-axis? 3/4 is a positive number. It's our x-coordinate. It's got to be moving to the right. It's got to be on the right side of the y. -1/2 is our y-coordinate. It's negative. It's got to be below the x. That puts us in quadrant positive for x, negative for y. Are you seeing why I wanted you to understand the nature of the values of your coordinates for the quadrants, so you know where your points are pretty darn quickly? If that's positive, that's negative. You're quadrant 4. We're somewhere between here. Try to do the best you can. I know it's not going to be perfect because we're dealing with fractions, but 3/4 isn't to 1 yet. -1/2, so 3/4 along the x, combined with the idea of -1/2, it's below the x, half a unit. That would be our j. Stop right now. See if you could, on your own, pick out some random points. Just start thinking numbers off the top of your head, pair them up, and see if you can plot them. If you can, awesome. Think about if you can go all through these numbers and tell me what quadrant each of these points is in. Stop. This is the way that I would do guided practice right now. I'd pause and I'd have you do that. So pause and do that. See if you can name the quadrants really quickly, or the axis that these points are on, or the origin that it's on. See if you can go backwards. See if you could erase this, or cover it up, and see if you can look at point C and get the coordinates from it. Do you understand that from C, you'd have to have the x value labeled first and then the y value? So you'd have to have -1, 4, not 4, -1. That would create a point that's way over here, something that we don't want to do. If you can do that, you're pretty much good with plotting. That's what plotting is. It's just taking a relationship among two variables, each of which has numbers, and putting them together on a combination of two number lines, one number line for each of those variables. That's the idea. We should be able to, at this point, readily identify our x-coordinate, identify our y-coordinate, and be able to put them on our number line in the correct quadrant. That's it. Now, the last thing that most teachers would have you do here is create a scatter plot with like real numbers. Because, I mean, why would we learn this if it doesn't relate to real stuff? Well, firstly, for fun. Sometimes, just studying math can be fun. Pure mathematics is interesting. It's really weird. Kind of cool. But also, because a lot of times in life, just looking at this and this and this and this and this and this on a list of numbers doesn't paint a really good picture. It doesn't allow people who might not be as skilled as math as you to get a feel for what the numbers are trying to tell you. So I'm going to give you an example of a scatter plot, one of our most basic graphs that can start illustrating a relationship between the numbers in a little bit more of a concrete fashion for most people.